Okay, quieten down, please. Okay, so before we get started with the work for today, I just want to go over what's going to happen with the test. Okay, remember we've got 1 week until the test. Okay, please do not let it sneak up on you. Okay, so the class test 1 will be 15 questions, 45 marks. So 5 questions on U substitution, 5 questions on integration by parts, and 5 questions on trig integrals. Okay, there will also be 5 bonus questions, however, those will be mixed. Okay, so I'm not telling you which method to use for those bonus questions. Okay, as with all of my tests, if you want to answer a question in 2 different ways, that's entirely fine. I'll give you the marks for both. For example, there might be a question where you can do it using the trig integral method, and you can do it with U substitution. If you show me both methods and they're both right, you get 10 out of 5. Okay, just as an example, so let's say we have sine x over 1 plus cos x, for example. Okay. Here there's only trig functions, so you could treat it as a trig integral. Or notice that if we look at the denominator, the derivative gives us the numerator. So we could do a U substitution. Okay, so you can do it both ways. If you get both methods right, you get the marks for both. Okay. The U substitution part, try do U substitution. Doing integration by parts might be too much work, okay, just because I make the U substitution simpler. But if you want to go for the bonus marks and do it both ways, I'm fine with that. Okay, get as many marks as you want. Okay, and then the 5 bonus marks, again, it's mixed, so I'm not going to tell you which method to use. If you pick one of them and you do it 3 different ways, so say you do a U substitution way, an integration by parts way, and a trig integrals way, maybe that comes up, you can do 1 question and get all 3 ways correct. Okay, so there's no limitation on which method to use. However, the questions are labeled with which method you should use. So that's the method that I think is the easiest for you to use, but that's not a limitation. You can use whatever method you like for whichever question. Yeah, but if you're stuck, just think question 1, U sub, that's what you should go for first. If you want to try something else, I'm not stopping you. Okay, so 45 marks, you'll have just over an hour to complete that. Okay, so roughly 5 minutes a question. Some questions you can do quite easily, okay, it won't take you 5 minutes. Other questions, if you're not too sure what to do, maybe a bit more than 5 minutes, but you should be aiming for 5 minutes a question, okay, to complete the test. Okay, any questions on that? Okay. Okay, so last time we went through trig integrals, and we had these 3 classes, or 3 groups that you can expect. So the ones with sine and cos with some powers, remember if they're both even, you do something. If they're both odd powers, you do something. If one's even, one's odd, you do something else. Okay, we went through those examples. Same for tan sec ones. Okay, if they're both odd powers, you do something. If they're both even powers, you do something else. If one's even, one's odd, there's something else that you do. Okay, we covered those examples as well. Okay, and lastly, if you have something like sine A cos B, sine A sin B, cos A cos B, we had those 3 trig identities that we used. Okay, I gave you 2 of them, and 1 was for homework. Okay, and I gave you a few more homework problems on that to try. Okay, so today we're going to go through the ones that we missed. So, for example, the sine and the cos, if they're both odd, then we're not sure which to factor out. We can factor out a sine, or we can factor out a cos. Okay, you can do both. And I said both methods will give you the same answer. Okay, so we're going to look at the ones like that. Okay, where there's 2 ways to do it, both will give you the right answer. Okay, and that's up to you. You can pick which way to go. Okay, so number 1. Here we have the integral sine cubed x cos cubed x dx. Okay, so here we don't know what to factor out. Do we factor out a cos and change everything to sine, or do we take out a sine and change everything else to cos? We don't know which to do. So let's do both ways and see what we get. So for the first way, I'm going to factor out a sine and change everything to cos, and we'll see what we get. Okay, so this is equal to the integral sine squared x cos cubed x, and I'm taking out the sine x. Okay, and I'll underline it like I did last time to say that all of this bit I want to be du at the end. Okay, so if I want that to be du, then I need to change the rest of it to cos stuff. So the sine squared, I'm going to change to something with cos. So that's going to be the integral 1 minus cos squared. Then we have cos cubed, and then we have sine x dx again. So if I let u be cos, then the du will take up this sine x dx. And remember the minus sign there. Okay, so this will be minus the integral 1 minus u squared, u cubed, and then everything else is taken up by the du. Okay, now this is just a polynomial in u, so we can multiply that out and then use the power rule. So this is minus the integral u cubed minus u to the 5 du. Okay, just a polynomial, easy stuff. So that's 1/4 u to the 4 minus 1/6 u to the 6 plus c. Okay, now remember what we had u was the cos. Okay, so we can put that back. So this will be minus 1/4 cos to the 4 plus 1/6 cos to the 6. Okay, and don't forget your plus c. Okay, remember for the test, plus c for indefinite integrals, no plus c for definite integrals. Okay, please do not lose marks on silly things like that. Okay, so this method, if we go back to the top, we decided take out a sine x, and we got that answer. What happens if we take out a cos x? We'll get a different looking answer, but in fact they're the same. Okay, and you can use trig identities to show that those are the same answers. Okay, so let's redo everything, but now taking out the cos. So we have sine cubed x, cos cubed x dx. Okay, so we're going to leave the sine cubed alone, and we're going to take out a cos. So that's going to be sine cubed x, cos squared x, and then we take out a cos, so that goes there. Okay, now we want this underlined bit to be du. We want to get rid of that. So we let u be sine x. If u is sine x, then this bit underlined here goes away with the du. Okay, but there we've got cos squared. We need to change that to sine. So this will be integral sine cubed x, 1 minus sine squared x, and then again the cos x dx. We want that to be our du. So we let u be sine, du will be cos x dx. That takes care of that. So here we can write this as the integral u cubed 1 minus u squared du. Okay, and again, same thing as the last one. Multiply it out, you get your polynomial. Just do the power rule, and then remember to put your sign back. Don't leave it in terms of u. Okay, that's unfinished at that point. So this will be the integral u cubed minus u to the 5 du. So we get 1/4 u to the 4 minus 1/6 u to the 6 plus c. Okay, and again, this is unfinished at the moment. We need to put the sign back. So that's easy to do. It's going to be 1/4 sine to the 4x minus 1/6 sine to the 6 plus c. Okay, please stop that talking. Okay, so here we have an answer in terms of sine. And then if we go back a bit, we get another answer in terms of cos. Okay, now you might think that the method was wrong. We got two different answers, but these two are actually the same. Okay. If we use trig identities on this, we can show that this answer is actually equal to this answer. Okay, they just look different, but it's just a trig identity difference. Okay, so I'll leave that as a little homework exercise, show that they are the same. Okay, show that the previous two answers are the same. Okay, so there are some trig identities that you can use to get from the first answer to the second, or the second answer to the first. It doesn't matter which way you go. Okay, so it's like your trig identities from high school. You pick a left-hand side and show that it equals the right-hand side. Okay, so I'll leave that for homework. Okay, so don't be scared if they look different. If your method is correct, then they are actually the same. And in the memo, I will put both answers so you can check. Okay, let's have a look at the next one. So for this question, we can also do it two different ways. The answers will look different, but they're actually the same, like we had before. So here we have the integral cos x sine 2x dx. Okay, so at first glance, this looks like that third type of problem we looked at with the cos A sine B, something like that. Okay, so we need that trig identity with the sum angle, difference angle, and so on. Okay, if you ever forget it, in the test you can just rederive it. So here, since we have cos and sine, we start off with sine A plus B. Okay, we know what that should be. That's going to be sine A cos B plus sine B cos A. Okay, they swap. Okay, then we have the same sort of thing, but with the minus sign. So now we have sine A minus B. That's going to be sine A cos B minus sine B cos A. Okay, now you don't have to do this every time, but if you forget, this is what you'd have to do. Okay, now we can add these two together. These terms on the right here will cancel, and we'll end up with what we want. So in this case, sine A cos B, that's going to be 1/2 of the left-hand side being summed up. So it'll be sine A plus B plus sine A minus B. Okay, so if you ever forget it, just quickly do this on the side, and then you get your identity. Okay, so here our A is going to be 2x, and then our B will be x. Okay, just looking at the A goes with the sine, the B goes with the cos, so we can just read it off there. Okay, so instead of integrating the product, we can then integrate that sum over there. So it's going to be 1/2 the integral sine A plus B, so it'll be 3x, plus, and then sine A minus B, that's just going to be x. dx. Okay, this is easy. We did this last semester. So the integral of sine, that's going to be minus cos. Yeah. So that's going to be minus 1/2 times 1/3 cos 3x. Okay, and again, integral of sine, that will be minus cos. So minus cos x plus c. Okay, and then the half and the third, we can make 1/6. So that's minus 1/6 cos 3x minus cos x plus c. Okay, so that's if we do it this way. So here we notice that it's a product, something like cos A sine B or sine A cos B. It doesn't matter which way you look at it. Okay, so we've got that product and we use this identity here, and we got this answer. But we could also do this another way. If we go back here, sine 2x, we can use our double angle formula and write it as 2 sine x cos x. So that's another way that we could manipulate the integral to solve it. So let's look at it that way. So if we try expand that out and try it that way. Okay, so we have the cos x sine 2x. Okay, so maybe you saw the double angle. Yeah.
So for the one example that now the half, does it get distributed to the sine, the cos, as well?
Yeah, sorry, that should be over 2. Yeah, so that should have been over both. Cool, thanks for that. Okay, so if we look at that double angle thing there, maybe you could see that we could write it as 2 sine x cos x. So let's write it like that. So that will be 2 integral cos x, and then this would be sine x cos x. Okay, please stop with the talking. Okay, so now we can multiply this out. We've got 2 cos terms over there. We can multiply it. So that's going to be 2 integral cos squared x sine x dx. Okay. It looks a bit more complicated than what we started with, but it's actually really easy. Because if we look, we've got cos squared, so we've got a cos there. The derivative of cos will be minus sine, and that will cancel this bit here. So you see we can do a u substitution on that. So if we let u be cos, then minus du will be sine x dx. Yeah, and that cancels the sine x dx on the side there. Okay, so this will be minus 2 integral. Now it just becomes u squared du. Okay, integrating this is very easy, just power rule. So we get minus 2 over 3 u cubed plus c. And then we can put the u back. So u was cos, we can put it back there. So this is going to be minus 2 over 3 cos cubed x plus c. And again, it looks very different to what we had before. So here, if we go back a bit, here we had minus 1 over 6 cos 3x minus cos x over 2. That looks very different to this. Okay, here we got cos cubed, but again, it's the same. If you use a trig identity on this one, you can get to the first one. If you use a trig identity on the first one, you can get to this one. Okay, it might be quite a few steps to get from one to the other, but it's just using your trig identities. There's nothing strange to do there. Okay, so if you want to try that for homework, you can do that. It's a bit more work than the previous one, but you can try it out. Okay, any questions so far? Okay, so everyone's happy with this 2 ways of doing the problem. Okay. I've got a few more to go through. So these ones were the sine and cosine. Remember, there's also the tan and the sec ones to go through. Okay, so here, number 3. Okay, so I'm only going to do this one way. I'll leave the other way for you to figure out. So here we have tan cubed, sec cubed. Okay, so first thing, what do we notice about the powers? Okay, they're both odd. What happens if they're both odd? We factor out sec tan. Okay, so here we can factor out a sec tan, and we're left with tan squared and sec squared. So this will be the integral tan squared, sec squared, and we took out a sec x tan x. Okay, and again, I'll underline that. We want to do a u substitution that then cancels this bit out. Okay, what u substitution will cancel that out? Sec. Good. So we let u be sec, and then du will then cancel that out. But here we've got tan squared, sec squared. The sec squared is fine. The tan squared is giving us problems. So let's change the tan squared to a sec squared. Okay, so that's the integral. We can write this as sec squared minus 1. Got another sec squared here, and the part that we factored out. Okay. Okay. As you said, we let u be sec. So here, this is going to be the integral u squared minus 1, another u squared, and the rest is taken up by du. Okay, and again, it's just a polynomial in u. Okay, so whenever you do these trig substitutions, you always end up with something like that, some polynomial. Okay, that's easy to work out. That's going to be u to the 4 minus u squared. Okay, standard stuff here, so that's 1 over 5. Sorry, that's a 5. U to the 5 minus 1 over 3 u cubed plus c. Okay, and remember what we did? We said u was sec, so we put that back in. Okay, so that's 1 over 5 sec to the 5 minus 1 over 3 sec cubed. Okay, so that's doing it like the standard way. Okay, right, both powers are odd, we factor out a sec x tan x. Okay, so that's the standard way, it's the easiest way to solve it. There might be another way to solve it. Okay, you could try something with integration by parts maybe. Okay, so you could try and differentiate the tan and you could try integrate the sec. Maybe that could work. Or you could do a trig substitution first. Maybe that would work. For example, the tan cubed, if you take out a tan, you're left with tan squared. Okay, you could try something with that. There's different ways of attacking these problems. Okay, so we should all know the standard way. Okay, please don't forget that way. But there are other ways. Okay, maybe the other ways are easier, maybe they're more difficult, but the more ways that you know, the better. Okay, if you get to a problem in a test and you've forgotten one way, or maybe you know 3 other ways, you can still answer it. But if you learn one way and you forget that one way, now you can't answer anything. Okay, so please do not limit yourself. Try multiple ways. Okay, it's only beneficial. Okay, there's no harm in knowing more than one way to solve a problem. Okay, so I'll leave that for homework. Think about another way of solving this. Maybe there's a way, maybe not, but just think about that. Okay, and then for the next one, something similar. So here, number 4. Okay, we have the integral tan x sec x dx. Okay, so this is one of those standard one-line integrals. Okay, remember this is the derivative of sec, right? So the antiderivative of this would then be sec, right? Going back and forth. So in one line we could write this as, this pen. So in one line we could just write the answer as sec, but what happens if we forget that, right? If you forget, well, now we need a different method. So again, knowing different methods will help. Okay, so here, let's just write the answer in one line. Okay, so here that's sec x plus c. Write one line because we know the derivative of sec is sec tan. Now, if we forgot that, we need to find a different way of tackling this problem. Okay, so what do we do? Well, with tan and sec, okay, if you forgot whatever we learned, the one thing that you need to remember is that tan is sine over cos, and sec is 1 over cos. So if you forget everything else, go back to what you know with sine and cos. So let's say tan and sec, forgot everything. Don't know any identities with that. But at least we know that tan can be written as sine over cos. Please never forget that part. And then sec, that's 1 over cos. Okay, So when in doubt, go back to sine and cos because they might be a bit easier to work with. Okay, so now we can write this as sine over cos squared. Okay, so this looks a bit more difficult than what we started with, but notice the denominator here, cos squared. If we let u be cos, du will be minus sine, and that takes care of the numerator. So we can actually do a u substitution here. So if we let u be cos, then minus du will be sine. And that takes care of the top there. So this now becomes minus 1 over u squared. Okay, or u to the minus 2, if you want to think about it like that. Integrating this, we get 1 over u plus c. U was cos, so this will be 1 over cos. Now, if you're really stuck, you can just leave it like that, that's fine. But remember here, sec was 1 over cos, so we can write this as sec. And we got the same answer. So we had no idea what to do with the sec tan. All we knew was this, that tan was sine over cos, and sec was 1 over cos. We didn't use any tan sec trig identities. Okay. We didn't even use the fact that the derivative of sec was sec tan. We imagine we didn't know any of that. So we wrote tan as sine over cos, sec as 1 over cos, and we just treated it like a u substitution problem. And we got the same answer. Okay, so even if you forget that the derivative of sec is sec tan, you can still answer the problem a different way. Okay, so this is what I mean by knowing multiple methods. Okay, you forget the one way, you got a backup plan. Okay, and if you forget this way, maybe there's a third backup plan. Okay, so don't just stick to one problem that we learn in class. So if I give you a problem like this, look at it in multiple ways. Try to solve it first way, second way, third way, maybe even a fourth way. Because when it comes to the test and you forget the first three, because you're really stressed, you got the fourth one. Okay. But if you only learn one way, now you can't answer anything. Okay. Especially with the exam. Remember, exam coming up end of the year. You're going to be sitting alone in the exam hall. Very stressful situation. Please know more than one way to answer the problem. Okay, I've seen this many times before, not with the maths, but with the physics on Westville. People come to the exam, they only learn what we do in class, they only learn one method, they get stressed out, and they leave the whole section out. What do I do? Okay, can't give part marks, can't do anything. Okay, please do not let that happen to you. Okay. Last problem for today, and then we're going to go on to some test revision Q&A stuff. Okay, so here we have the integral 1 over 1 plus cos. Okay, we covered this, something similar before when we were doing the u substitution. Okay, what do we do? There's no powers, right, it's not like cos cubed or cos squared, can't do anything like that. 1 over 1 plus cos. And it's not even cos squared, right? If it was cos squared, we could do something with an identity. So why don't we try and change it to get to cos squared? Once we have something with cos squared, we can start using identities. As it's written here, there's nothing we can do. So here we have 1 plus cos x. Think of it as the 1/2 of difference of squares. Remember, a plus b, a minus b. This is 1/2 of that. So if this is the a plus b part, the other part of the difference of squares will be a minus b. So 1 minus cos. So let's multiply the top and the bottom by 1 minus cos so that the bottom becomes a difference of squares. So this becomes the integral 1 minus cos over 1 plus cos x 1 minus cos x. Okay, so the 1 minus cos x at the top, the 1 minus cos x at the bottom, that's just multiplying by 1, right? We haven't done anything there. But now the bottom is the factored form for difference of squares, right? A plus b, a minus b. So multiplying that out, we get 1 minus cos squared. Right, it's just reverse dots. So here we have 1 minus cos x over 1 minus cos squared. Big star there because that's what we wanted. We wanted cos squared. Why? Because all of the trig identities have cos squared in them. So 1 minus cos squared, that's sine squared. Good. So that's the integral 1 minus cos over sine squared. Okay, again, it still looks a bit complicated, but notice we have a single denominator. We can split this up into 2 fractions, and then just treat them separately. So we have 1 over sine squared minus cos x. I'm going to write this as sine x times sine x. Okay, so we can just think of this as one grouping there. Okay, 1 over sine squared, that's cos x squared. Okay, and then with the grouping, the reason I wanted to group it is cos over sine, that's going to be cotan. And then the leftover bit, let's just put a times 1. The 1 over sine, that will then be cosec. Okay. And we did that last semester with the trig derivatives. The first one, that's going to be minus cotan. And then the other one will be minus cosec, but we got the minus there in front. So minus and a minus, that will be a plus. Plus c. Okay. So remember your minus signs with these co-functions. So cotan, cosec, and so on. Remember which derivatives have that minus sign. Okay, so the derivative of tan is sec squared. The derivative of cotan is minus cosec squared. You got that extra minus sign there. The derivative of sec is sec tan. The derivative of cosec is minus cosec cotan. Okay, you got that extra minus sign there with these co-trig functions. Okay, any questions on this one? Okay, so again, if you got something like this, where it's not like that standard form, we want to use trig identities. So here, cos doesn't help us. Cos squared does help us. So we multiply by this 1, which is 1 minus cos x over 1 minus cos x. And that gives us the cos squared that we need. Once we've got the cos squared, the rest is just trig identities and antiderivatives. Okay. So if we had 1 over 1 plus sine x, we want sine squared. What do we multiply by? 1 minus. Good. Okay. And it works for whatever that denominator looks like. Okay. Any questions on these 5 problems? No questions. Everyone's happy. Okay. So for the rest of the lecture, I'm open to your questions for the test. Remember, the test will be U substitution. So I'll go through the scope again. So 15 questions, 5 questions on U substitution, 5 questions on integration by parts, 5 questions on trig integrals, like this stuff here. Okay, and then 5 bonus questions, which are mixed. Okay, I'm not telling you what to use for those. Okay, so altogether 45 marks. Okay, and you'll have roughly 5 minutes for each question. So some questions, it will be less than 5 minutes, some questions a bit more than 5 minutes, but you should be aiming for roughly 5 minutes. Okay, so if you can't answer these questions within 5 minutes, Okay, there's no way you're answering the test questions within 5 minutes. Okay, so please make sure you go through the homework problems, the tutorial problems, and the quiz problems. If there's questions there that are taking you too long to solve, come to me, email me, do something. Don't just leave it, right? If it's taking you too long to solve it or you don't know how to solve it, you're going to have problems for the test. Okay. Okay, so any questions on those 3 topics? Okay, so we won't go back to that. Next week we need to start the new chapter. So these 3 things, we're done with that by the end of today. Okay, anything, tutorials, quizzes, stuff you found online, anything at all? Yeah. Quiz 2. Okay, let's have a look at quiz 2. Let's see here. Okay, that was quiz. Can you see that there? Okay, anything specific from here? Number 1. Okay, sure. 145. Okay, number 5. I won't go through the full thing. It's exactly the same as number 1. Here you just do a u substitution with root x. You do the u substitution with root x, and you get exactly the same thing as number 1. Okay, please look at the memo for that. But I'll go through that. So this was quiz 2, number 1. Okay, so this was your standard integration by parts. Remember, at the end of the integration by parts chapter, I gave you those guidelines on what to let u be and what to let dv be. Okay, if you have an inverse trig function, you let that be u. Right, that was in the guidelines that I gave you. So u is equal to arctan x. Once you make that choice, everything else is just dv. Okay, so du, that's 1 over 1 plus x squared dx. We've done that many times now. And then integrating x, that's just half x squared. Okay. Okay, so now we just put it together, right? So using that formula, that was integral u dv, uv minus integral v du. Okay, you should all know the formula by now. Okay, so u times v, that's going to be the 1/2 x squared and the arctan. Okay, minus v du, that's going to be minus 1/2 integral x squared over 1 plus x squared. Okay, now this bit, you can do a number of ways. In the quiz memo, I think I did it 3 different ways. Okay, I think there are three ways you could do that. The easiest way, okay, you can use whichever way, I'm not limiting you, but the easiest way, for me at least, is to write it like this. Sorry, that's arctan. Here, notice that the denominator is 1 plus x squared. The numerator is just x squared. The numerator is almost the denominator, apart from the 1. So what I'm going to do is add a 0 to the numerator, but a very specific 0. I'm going to write it as plus 1 minus 1. Okay, I haven't added anything, because plus 1 minus 1 is just 0. But look what we can do now with this fraction. Okay, let's just change the color here. This bit, x squared plus 1 over 1 plus x squared, that's just 1. So here we can write this as 1/2 x squared arctan x minus 1/2, 1 minus 1 over 1 plus x squared. Okay, nice little trick. So if the numerator is almost the denominator, you can just try and make it look like the denominator. We get this. Integrating this is very easy. We get 1/2 x squared arctan x minus 1/2 x plus 1/2 arctan x plus c. Okay, so I like that method, but in the memo I did show 3 other ways of doing it. So if you didn't see this way, there's at least 3 other ways to solve it. Okay, so that's for the first one. And then you said the fourth one. Fourth one, the Lin one. Okay, sure. This one, I think there are 2 ways that I thought of. I put that in the memo. There could be more, but that's just what I thought of. 1 plus x squared dx. So here, if you have no idea what to do, we let u be the natural log, okay, right, because that's easy to differentiate, and then dv is everything else. So u is the natural log, 1 plus x squared, dv is dx. Okay, again, this isn't the only way. There's lots of ways, but this is just one of the ways I thought of. So du, that will be 2x over 1 plus x squared. And then v is x. Okay, a lot of you were not using the chain rule on u. Okay, look here, we've got this outside function, which is the natural log. Differentiating that, we have 1 over the stuff inside. But you need to use the chain rule. You still need to differentiate the stuff inside. So we get the 2x. Okay. More than half of you were leaving it as 1 over 1 plus x squared. Okay, please use the chain rule when you've got that composition like that. Okay, now we just put all the stuff together. So integral u dv, that's uv minus integral v du. uv, that's the x log 1 plus x squared, minus integral v du, that's very similar to the first one, just got a 2 there. Okay, so again here there's 3 different ways of solving this. Please look at the memo for the other ways. Okay, I'm just going to do the +1 -1 just for time. Okay, there are other ways. You can do a u substitution, you can do it by parts, and there's another way in the memo, I can't remember that one. Okay, I hope everyone is looking at the memo for those alternate ways. Okay, so that's going to be 1 plus x squared minus 1 over 1 plus x squared. Okay, so that's x ln 1 plus x squared minus 2, that's going to be x minus tan inverse x plus c, so that will be x ln 1 plus x squared minus 2x plus 2 arc tan x plus c. Okay, again, that's just one way, right? There's at least 2 other ways of doing that. Okay, so that's the one way from the memo. If you want to look at the other 2, please just look at those solutions I posted. Okay, and then the last one, like I said, here you just do a u substitution first with the root x, and then it becomes exactly the same as question 1. So it was one step difference. Okay, anything else? Yeah.
I want you to explain the integral of sin A and B. Is that I found two shortcuts to doing, so I want you to continue.
Yeah, if you got shortcuts, that's fine.
So if you have the integral of sin A, sin B.
Well, let me write that down quick. Integral sin A, sin B. Yeah.
If A is greater than B,
Yeah.
then you could say sin A minus B over 2 times the derivative of A minus B minus sin A plus B over 2 times the derivative of A.
The derivative. Okay, that sounds a bit longer than the other method. Just see me afterwards. I just need to check that. But if it works, that's fine. It's fine with me. Okay, I think with the derivatives, when you integrate the derivative, you get back the function. I think it's something like that. Just show me afterwards, I'll have a look. Okay, but if it works for you, I'm fine with that. Okay, anything else? Okay, remember I'm not going over the stuff again. Next week we got to start the new chapter. Okay, I thought there would be more questions considering the quiz marks were so low. Yeah. Quiz on Monday. Yeah. Yeah, there'll be a quiz on trig integrals. Yeah, same stuff as we did last year, right? Quiz the next week based on the stuff we did the previous week. Yeah, so before the test, we would have done a quiz on each chapter and a tutorial on each chapter. So you'll have everything you need for the test. Okay, remember, everyone's adults. If you don't ask questions and you end up failing, I cannot help you. Okay, the exam is counting 50% of your year mark. If your class mark is not at 50%, that's more stress for the exam. So please do as much as you can with your class mark while you can now. Okay, because once you get to the exam, that's it. All you have left is the exam to do. Okay, please do not take these quizzes and stuff lightly. They add up, right? 50%, it's quite a bit. Okay, same thing with the class test, right? They're counting a bit more than the quizzes. So, any questions on those three chapters? Last chance. Okay.